There we are. Okay. Ooh, got that working. Hello, everybody. How are you doing? Record's working good. Okay. How can I help you today? You guys get a chance to look at those sample tests? I didn't get any. I sent out a couple, a message asking you guys if those were going okay. I didn't hear back.
Where are those located?
Let's see. If you go under your videos, the sample exam one is there, and it comes up as a Excel document, or not Excel document, a Word document. And then the solutions are videos of us going through those problems. So yeah, it's got some average rate of change, some difference quotient, some building the equation of the lines, a couple of nice word problems. You guys get.
I have a question for chapters 1 through 3 review. Can we look over question 19? Because when we were doing it in our homework section, that was one of our homework questions too. I got a little confused with it.
Okay. So you're meaning the review that's down here, right?
Yeah.
Number 19.
Wait.
That one?
Yes.
Okay. So let's see. The graph is shown red, so you've got some function here in red. And it wants us to draw the graph of 1/2 f of x. So the key is that what is the translation or transformation of this multiplying by 1/2 gonna do? The big thing is with these transformations is to look at whether or not it's happening inside the function or outside the function. And this 1/2 is outside of that function. We're taking the function values, essentially the y values, and multiplying them by 1/2. As opposed to this +3, that +3 is happening inside the function before the function takes place. So it's happening to the x values. So what's that 1/2 going to do to the y values? Well, it's going to multiply them all by 1/2 and essentially compress this image vertically. It's going to, essentially squish it to 1/2 of its height. If this was a 5, it would multiply it by 5, so it would stretch it out 5 times its height. But this little 1/2 is going to make everything 1/2 the size. So if we tried to pull in on this a bit, so the x values of all our coordinates aren't going to change. It's just the y values are going to be multiplied by that 1/2. So this point here at -1/8 is going to become -1/4. It's going to become 1/2 the size. Okay. The point here at -4 is 0. Well, 1/2 of the 0 is 0. So we're going to go from there to there. That takes all those points and just takes their y values and halves them. Fair? Similarly, we should be going through that same 0 point there, but that value here at 4, -4 Half of that -4 is -2, so should end right there. So it's just squishing it without a horizontal compression. So just a vertical compression. Here, we've got two transformations going on. We have the negative on the outside, and that negative on the outside is going to do that same kind of thing. It's going to take all our y values and multiply them by -1, which is going to take that image and flip it vertically. So if we just looked at what that negative would do, what that negative would do would be to turn this, say, -1 into a +1. It would turn this y value of 4 to a y value at -4 in the same location. And this endpoint at -2 would change to +2. So if we just looked at that negative and nothing else, it would just do that flip. Fair? But we have more than that going on. We also have this +3. Now, as I said, that +3 is happening inside the function, which means it's happening to our x values. That means it's going to be moving things left and right, right? The weird thing, or the thing that seems weird, when things happen inside the function, they always seem to happen backwards. Is that something you guys have noticed, that it always seems backwards when it's inside? Now, there's a couple ways to think about why that's happening, but one of the good ones, I think, is because that x+3 is happening to the x values, it's happening to the values before the function exists. Fair? So that red function doesn't exist yet. We're adding 3 to the inputs. So that's essentially is taking our inputs, our x-axis, and moving it in the positive direction 3 units. But what's that going to make the graph look like it does? If we take that x-axis and move it this way, that makes it look like the graph moved backwards. Fair? Essentially, the axes are moving out from under the function. But because we tend to draw the function, not the axes, it looks like the function itself goes the reverse. So it's going to, take this 3 and move that 3 forward to a 6, but it's going to make it look like the function went backwards. So this point at 4 here is going to want to end up at 1 instead. Because again, that graph moved out from under it. That point at -1 is going to want to be at -4. That point at -4 is going to want to be at -7. So again, if we isolate just the x+3, that f of x+3, it's going to move the axes forward 3 out from under that function, which is going to make the function appear to move in the negative direction 3. Now, generally, we just focus on what's happening to the actual image of the graph. So we just say it goes to the left 3. But if you're thrown off by why is that all happening backwards, that can kind of, help. Why is it graphing backwards? Because it's actually moving the world the function is in, not the function itself. Now, if we want to do both of these at the same time, we have to do both this move back by 3 and the flip upside down. So we're not going to be at this point. We're going to be at its vertical reflection. So we're going to be up here and then down and then up to there. Oops, up to there. But we have to do that all at once. So we're going to go back 1, 2, 3, and then reflect from -1 to +1. So that's where that point's going to land. This point has to go back 1, 2, 3, and then flip from +4 to -4. This point has to go back 1, 2, 3, and then flip from -2 to +2. Fair? Is there another one? Ooh, there's another one. Again, this 3 here, it's outside the function, so it's only affecting us up and down. Excuse me. So it's taking our y values, and it's taking those function values, those y values, and multiplying them by 3. So the points at the zeros aren't going to change, but everything off of that is going to triple. So that point at -4 is 0. 0 times 3 is still 0, so that's going to be there. And it's going to go in a straight line, each one of these points 3 times as high, until it reaches this point at -1, 2, which is going to be up here at -1, 6 when it multiplies by 3. So from there to there. That seem reasonable? And then this point, we could track any of these points that we want to, but because these are straight lines, the endpoints are nice to track. So this endpoint at 4, -3, the y value of -3 times 3 is -9. So it's going to be all the way down here at -9. So it really is just taking that image and kind of stretching it to 3 times the size.
Would that negative have any impact on that since it's a -3?
Nope. That -3 times 3 just becomes -9. And one of the things, if we even just had the points, so let's say take that point -3, -4, and if our function was, I was going to make up one actually, g of x equals, say, 5 f of x minus 2. And we wanted to figure out where does this point end up under this translation. Well, the translation says that x minus 2, but we know that -2 is actually going to add 2, right? Because it's backwards in there. So we take, and frankly, it's because that has to equal -3. So our x has to be at -1. That's another reason why you have to think about why is it all backwards, because we technically have to solve, if that helps. But that adding 2 to that -3 puts us at -1. And then that 5 being multiplied by the y value, 5 times -4 is -20. That point is going to land at that location. So the graph can be super helpful, but really it is just a mechanical multiple. That 3 times the -3, -9, that's where our point lands. You might notice that it does that vertical stretch. We are being stretched away from that x-axis. So if you're positive, that stretch makes you more positive. If you're negative, that stretch makes you more negative. But it's not going to change you from negative to positive unless that was a -3, in which case the whole thing would just flip upside down. Fair? Ooh, there's more of those. How many of these are this last one? Ooh, this one has a lot of negatives. So again, this negative out in front, that negative is inside the function. So that's affecting our x's. So that's going to switch us left and right. So a horizontal reflection. That -5 is outside the function. So it's going to take all our y values and drop them by 5. And again, we could take those points. Oops. I'm going to move this over here so I can write on it. We could just take the points -1, -4, the point -4, -1. That's weird. And the point 4, -2. And just perform that translation to it. Our new function is our old function with a horizontal reflection and a vertical translation by -5. So what's going to happen? That's going to multiply our x's by -1. So our x's are going to become +1, +4, and -4. And that's going to subtract 5 from the y's. So -9, -6, and -7. Isn't this a +4? Sorry, it's a +4. Sorry about that. Okay, that's this +4 up there. So we could do those translations over there and do them just strictly mechanically from the algebra, or we could do them graphically. Same thing either way, really. That negative value takes this value at -4 and puts it over at +4, turns that where am I? That -1 and pulls it down by 6. So we end up at this point over here at 4, -6. So it goes from -4 to +4 and then drops down by 6. This point goes from -1 to +1 and drops down 1, 2, 3, 4, 5, 6 to there. This point goes from -4 to +4 and then drops down 1, 2, 3, 4, 5, 6. And that's that image rotated and then dropped by 5. Fair. And one of the things to keep in mind, one of the goals of being comfortable with this process is for when somebody gives us something like when we are dealing with a function like this and we're like, well, what does this function look like? How does it behave? Where is it increasing? Where is it decreasing? And ideally, we know what basic square root of x looks like. Basic square root of x is that function, right? And we know some points on it. It goes through the point, the square root of 1 is 1, square root of 9 is 3, square root of 4 is 2. So we have some points on that graph. What does this graph look like? Well, it's going to go that way 4 units. It's going to stretch out this way by 3 units. And it's going to go up 1 unit. From our horizontal shift, our vertical stretch, and our vertical lift. So what's this thing going to do? Well, it's going to go that way 4, and it's going to stretch to 3 times the size, and then it's going to lift up 1. So that graph of this function is going to look, we know kind of where it is just by knowing what those transformations do. Fair? And if we wanted to track, like, where's this point? Oops. Where's that point? So we knew our domain or whatnot. Well, that point at 0, 0, what did it do? It went that way 4 and up 1. So that point's at 4, 1. Cool. And this is really helpful when you start dealing with more and more kind of weird transformations of functions, particularly those of you going into trig, when you start dealing with the sinusoidal functions. And you've got to take that sinusoidal function and modify it so it starts at a particular place, has a particular amplitude, has a particular frequency, and you got to get the curve to do what you want it to do. We use these types of transformations to do that. Horizontal compression to make the frequency, vertical stretching to control amplitude, vertical shifts or lifts to control equilibrium. It's all done in this kind of way. So 19, did that help? Okay. Now, actually, I was going to make a comment about 20. You remember when we were doing quadratics, we talked about that vertex form of a quadratic, that a x minus h squared plus k, right? Where the vertex was that hk location. And, we did that from a very quadratic perspective. But if you just look at, well, what does y equals x squared look like? Well, we know y equals x squared is just that basic parabola. Well, instead of having this defined as your vertex just because, this is a horizontal shift that way by h, a vertical lift that way by k. Well, of course, that's going to put your vertex up at the point hk. Fair? And then what does this a do? Well, that a just stretches it out, makes it, tall and tight, or if that a is small, it makes it wide and flat. But it does move your vertex just that h over k up. So is your vertex at hk because of completing the square and solving, or is it that your vertex because of function transformations? It's the same thing, either way. So if we wanted to draw this, are we doing it from a translation perspective in 3-5, or from a 3-2, 3-3 perspective? It doesn't matter. The vertex is going to be at 3-4. It's opening downward, and instead of going over one up one, it's going to be going down twice as much. So that's the graph. Normally a parabola goes to 1-1. So instead of going to 1-1, going over one up one, it's going twice as much. So over one, down two because it's negative. And that's a picture of our graph. People often ask, particularly when you get into calculus or some of the business classes, you'll see some big function and you'll just go, oh, okay, so that function has to be here. So our domain is this, and our range is going to be that, and these are going to be our points of interest. We will go, well, how can you just look at a graph and know that? This is part of that, how do we just look at a graph and know what it's trying to tell us? Knowing what these translations mean. So we can just go from, okay, I know what x squared looks like, or I know what a square root looks like, or I know what a third degree polynomial looks like. What are these things telling me individually about how it's moved around? It can be a surprising amount of information. All right. What else you guys want to look at? Anything else from this review? So yeah, this is just a vertical reflection, so that would be what, negative square root of x. That's a horizontal reflection, so square root of negative x. So, questions? What do you guys got? Guys being quiet makes me nervous. Makes the big dog nervous too. So let's say, for sake of argument, somebody gave you a function, say 2x squared minus x, and said, evaluate the difference quotient, and even reminded you that the difference quotient was that, and then gave you a whole bunch of space to do that in. Are you comfortable evaluating that difference quotient? Throw that out real quick. It's like number 12. Decreasing. This is the part most people miss. -1. Anybody forget that -1? Yeah. It's easy to do. They cancel. They go away. H divided by H is 1, of course. Easy to forget, though, when you're just kind of hacking stuff off. Guys happy with that process? I think I've asked you guys before, but how many of you guys plan on maybe possibly taking calculus? Or definitely taking calculus? That's some I don't knows. Sounds like some maybes out there. Anybody like know they're going to do it? Like definitely, absolutely going that way. Well, I'll keep trying to talk you into it here and there. So anything in this process that throws you off? All right. Let's see. Something common to need to do. Let's say given, how about, y equals x squared minus, yeah, let's go minus 2x minus 9. Is that what I want? Sure, why not? Find, we should be able to find x-intercepts. We should be able to find y-intercepts. We should be able to find a vertex. It's a parabola, so it should have an axis of symmetry. Not too worried about axis of symmetry, but it's something that'll come up vocabulary-wise. And we should be able to draw a graph. So again, I'll give you a couple minutes, find all those things. So let's see. I want to be real specific here because there are some tools that we use for quadratics. There's a bunch of tools we use just for quadratics, but there's also kind of some generalizations, particularly for intercepts. So there's one thing you want to think of whenever you're thinking of x-intercepts. How do we find x-intercepts, not just for quadratics, but how do we find x-intercepts for anything? The only thing we know about x-intercepts, all x-intercepts, is that the y value, well, yeah, for x-intercepts, we know that the y value is equal to 0. Any x-intercept, the definition, what it means to be an x-intercept, is that that y value is equal to 0. So how do we find x-intercepts? We let the y value equal 0 and solve. Similarly, how do we find x-intercepts? There's lots of different ways to find x-intercepts depending on what you're given, what form it's in. There's a lot of things about, oh, it's the constant. That actually depends a lot on the form. But similarly, what do we know about every y-intercept, no matter what? Is that the x value has to be 0. Wherever the x value is 0, what's remaining is going to be the y-intercept. Fair? So this is true not just for quadratics, but anything. So as we go on to finding higher degree polynomials and exponential functions and linear functions, logarithmic functions, as you go along, these are guidelines that never go away. To find x-intercepts, let your y equal 0. To find y-intercepts, let your x equal 0. Y-intercepts are usually easier to find because we're often already set equal to y. So it just comes down to evaluating the function at 0. And zeros tend to evaluate very nicely. So finding the y-intercept there, it's fairly nice. Y-intercept is a coordinate, is a point. So we should really be answering that as a coordinate. X-intercepts are usually a little harder to find because they have some sort of solving technique behind them. But we're still going to do that same thing and let our y equal 0. So 0 equal to x squared minus 2x minus 9. What tools did you use for trying to solve that for x?
I did completing the square.
Completing the square is a nice choice here. It would have been good to try to factor it, but that's not factorable. You always kind of want to check factoring first. If factoring doesn't work, quadratic formula, of course, works. You could have done quadratic formula. But with those numbers, I agree, completing the square is kind of nice there. But quadratic formula would get you the same thing. But in completing the square, I'd probably add the 9 to both sides. You don't have to, but I think it's nice. Half of -2 is -1. -1 squared is +1. So we'd be adding 1 to both sides to get our x minus 1 quantity squared equal to 10. Then square root both sides, plus or minus the square root of 10 is x minus 1. Then add the 1 to both sides. 1 plus or minus the square root of 10 equals x. Now again, what if you didn't want to do that and you really like quadratic formula instead? Well, that's fine too. It's x equals what, -b plus or minus the square root of b squared minus 4ac all over 2a. And I believe I went really fast through the construction of that by completing the square. So we know that's really the same thing as completing the square anyway. But But that would be what, -2 plus or minus the square root of b squared is 4 minus 4 times 1 times -9 all over 2 times 1, so 2. Is that right? Nope, that's +2. The opposite of that. So 2 plus or minus the square root of 4 plus 36 over 2. So 2 plus or minus the square root of 40 over 2. So 2 plus or minus 2 square root of 10 over 2. So 1 plus or minus the square root of 10. Same answer. I agree with you. And completing the square is a little bit nicer there than the whole quadratic formula. But either way. You guys happy with that in either case? So if we want to start looking at a graph of this, we've got our y-intercept at 0, -9. So it's down there.
Hey, Matt.
Yep.
Really quick question. I was looking at the test scratch paper and we can't turn it in. It's
Why not?
not available anymore.
It should open up on Mondays today, so it should have opened up.
Yeah, it's not open.
Okay, I'll fix that.
Okay, thank you.
Yep, thank you for letting me know. And if it gives you any trouble, you can scan it and then just send it to me as a message or an email or something if it fights with you. I'm too much, but as soon as we're done, I'll go and try to fix it. The 1 plus or minus the square root of 10, people often get nervous about how am I supposed to graph that? But what is the square root of 10? Square root of 10 is roughly 3. It's 3 and change, right? It's 3-ish. So what's 1 plus 3-ish? 1 plus 3-ish is 4-ish. So it's going to be right there. 1 plus the square root of 10. 1 minus 3-ish is -2-ish. So 1, 2, 3. 4. So -2-ish, it's going to be right there. 1 minus the square root of 10. How do I know that's exactly where 1 minus the square root of 10 is? Because that's where I put the dot. And I labeled it. So that's exactly where it is. Fair? I always find that to be a fun question. You ask a room full of fairly sophisticated math people, what is the square root of 50? And they go, I don't know what the square root of 50 is. How am I supposed to know what the square root of 50 is? And you go, okay, what's the square root of 49? And we all go, 7. And you go, okay, what's the square root of 50? I have no idea. You have no idea what the square. What's the square root of 50 about? 7. Okay, it's 7-ish. But you got to kind of allow yourself to do that. 1 plus the square root of 10. How am I supposed to know where that is? Well, it's 1 plus a little more than 3. Okay, right there. Fair? Okay. So we know it's going to open this way. We just kind of want to figure out where that vertex is. How do you want to find the vertex? Got a couple of tools. They're really the same tool, but a couple different methodologies. What's your preference? No preference? No feelings? No deep emotional ties?
I prefer I always forget what it's called, the quadratic one. The longer one, just because I'm more familiar with it. I think completing the square is still frightening.
So when you mean the longer one, which one do you mean? Like this thing?
Yes.
Well, that's the quadratic formula.
Right.
and it will not find a vertex.
Oh, sorry. I misunderstood the question.
That's okay. I kind of like that actually, because for a lot of people, you say, hey, I've got a quadratic. What are you going to do? And they'll go quadratic formula. And that's great if you wanted x-intercepts, or if you wanted it solved equal to 0. Because really, that's unfortunately all the quadratic formula does, is it solves a quadratic that has been set equal to 0. If we're trying to find anything else, the quadratic formula is not a helpful tool. Fair? For example, if we want to find a vertex, what are we going to do instead?
It looks like vertex form would be the fastest.
Probably, especially in this case. That vertex form is that HK form we had up there. So again, we got to figure out what are we going to add to make a perfect square. Same thing we did up here. Half of -2 is -1. -1 squared is 1. I want this to stay y equals, so I'm not going to add the 1 to both sides like I did up here. I'm going to add the 1 and then subtract it. That'll keep my, oops, that'll keep my balance in the same way. So add 1 and subtract 1 means we've essentially added 0 onto this, right? We can add 0 anytime you want. Now this part factors as a perfect square because we just built it to. And then we're left with that -10. Fair. So then where's our vertex? Our vertex is at 1, -10. So down here, that's 1, -10. So that's the vertex form option. Now you also have, if you don't like completing the square, as apparently some of you still don't like completing the square, which isn't the worst thing in the world, but you want to get really, comfortable with it. We also have that vertex formula that the x value of the vertex is -b over 2a, right? Now, of course, we've talked about that formula comes from completing the square. It's just like this. Do you want to do it in, with a formula? So you're just following an algorithm, or do you want to do it, do the mechanics behind? Really kind of depend on what the numbers are. In this question, I certainly agree that completing the square was just nice, so might as well complete the square, but we have this tool too. So in this case, our b is that -2, so the opposite of -2 divided by 2 times our a is 1. Is nice having an a of 1. And we'll get, 2 over 2, we'll get 1. So that's nice and fast too. We do have to plug that 1 back in to find the y value. But that's also not bad here. And we get that same -10. Either way works. Personal preference. I would be comfortable doing it in both methodologies because really, which one you want to use, which one's nicer or faster does depend on what you've got in your particular problem. But both of these skills will come in handy for other things. In some ways, the disadvantage of the quadratic formula and the vertex form is the quadratic formula works for quadratics that are that equal to 0. Vertex form works for quadratics in standard form, but they don't really work for anything else. Completing the square is effective for all kinds of different other tools and other techniques. So I do think it's good to know both and be fairly comfortable with both. Fair? Oh, and the axis of symmetry is just that line through the vertex. So in this case, it's x equals 1. It's where the parabola reflects on itself. Questions about any of that? All right. Anything else I can do for you before most of you trundle off today? Okay, if anything comes up, let me know. I will go in a couple of minutes and try to fix that scratch paper thing, but if that does argue with you later, just send it to me as a message or email. I'm attachment, and that usually works fine too. Okay. Have a wonderful day, and I'll hang around for a minute to talk with you, Clark.
I also had a quick, sorry.
It's okay.
Sorry.
Oh, you're fine. I had a personal question about the test. I'm
Okay.
not sure if you can answer. I had taken it on the day it was
Right.
first due, because I wasn't able to see if it was postponed or not, and I just didn't want to miss out on it, and I wasn't sure if you had graded that or not.
It graded
wasn't-
automatically. I haven't looked back through it, but I did send you a message yesterday asking if you wanted to have that reset so you could do it with the extra time that we've had to practice.
Mhm.
Did
I just
you-
wasn't able to access what score I got on. 'Cause
Really?
for some reason, it doesn't show up in my grade book on my open math.
What does it show up as?
It doesn't. Let me pull it up. Try to see.
Because that's weird.
Mhm. It just shows up as not available.
Oh. I don't know why that would be. Oh, maybe I do. So yes, I have a score for you. It should be showing it to you, but I don't know why it's not, but I can go in and check why it's not and find out.
Okay.
And I can message it to you if you want.
Yeah, that would be awesome.
Okay. And then let me know if you want. I'll just send it right now. It just has a little blank message. And you can let me know if you want me to void that so you can play with it more, having had extra time for practice.
And did you message it to me?
Yes.
Okay. On my open math or on Zoom?
On my open math.
Okay. That makes more sense.
Zoom would have worked nice too, though. That would have been maybe a better idea.
Oh, don't worry about it. Perfect. All right. Sweet. Thank you. Is it okay if I message you later
Absolutely.
regarding that? Okay. Thank you.
Mhm.
Perfect. Bye.
Bye. Yes.
Okay, so I was looking looking at my grades and I went into the hand and homework and I said I have no grade for either of them, and that has brought my grade down significantly. So
That's on your side. My side has them, and I can update those.
okay, yeah.
Yep.
Because it says I got zeros on both of them, which I know I didn't.
No, that's just, it hasn't pushed over to your side.
Okay.
I can fix that right now just by pushing those up. And push that score up. Yep. Anytime something like that happens, it's not showing. Really, nothing should ever have a zero. You know, I'll at least put a point on something just so we know it's gone through. And you know, I don't think I've ever even had to do that. You know, there's always been something I can give some points for. You know.
Okay.
So if anything ever stays a zero, just let me know and I can fix it.
Okay, and also I think the review for the test is being counted as one of my grades.
No, it's showing, but it's
on my
not.
grade.
But it's on at least on my side, it says, I can show you, this was nobody else here. It has it as, you know, it has a score for it, but it says not counted. It's not put into your overall score.
Well, can you scroll down and look at my overall score? Yeah.
Yeah.
Weighted total. That's why I'm concerned.
Well, that weighted total is from this test score, the homework, and the hand-in. So that hand-in having points now should have, you know, changed that a lot.
Okay.
But yeah, this, if that 25 was in there, it would have changed this homework percentage a fair amount.
Okay.
And I can go in and make sure that that's not doing anything.
Okay.
But yeah, that's 70. Yeah, I can go in and,
Yeah, I was just making sure.
oh
because,
yeah,
like,
it's this one.
85.
Yeah. Why this is a little bit lower is because this zero is being added into that. That homework's not due yet. You still have some time, but that's, as soon as you open it, it figures it into your percentage. So
And
the fact that
why my
that's
grade dropped like that.
right. So the fact that that's in progress, that will change as soon as you know,
Okay.
finish it.
Yeah, I was just looking through. I'm like, oh my gosh. Like,
Yeah.
Okay, sounds good.
Anything else I can do for you?
Nope. Thank you.
No problem. And I'll go through the tests and look for partial credit and stuff. So this score will likely go up.
Okay, yeah, and I also messaged you my scratch paper just because I did not want to go over that 30 limit timeline.
Yeah, that's no problem. Good,
Okay.
perfect.
Sounds good. Thank you.
Mhm.